Hello everyone, this is Wico Dumancas and Jenn Magapan. Welcome back to the Liceo Math Club YouTube channel. Today we will discuss about verifying trigonometric identities.
Verifying trigonometric identities. To verify an identity means to prove that the equation is true by showing that both sides equal one another. There is no set method that can be applied to verifying identities. There are, however, a few different ways to start based on the identity which is to be verified. Trigonometric identities are used in both course text and in real-life applications to abbreviate trigonometric expressions. What are trigonometric identities? Trigonometric identities are equalities that involve trigonometric functions and are true for every value of the occurring variables where both sides of the equality are defined. For right angles, the 6 most used identities are sine, tangent, cotangent, cosine, secant, and cosecant. Okay, let's review. In learning trigonometry, these are the 6 most basic yet essential aspects in the said subject. These elaborated terms are the trigonometric ratios, where these are called as sine theta, cosine theta, and tangent theta. On the right, we have cosecant theta, which is simply 1 over sine theta. Next is the secant theta, which is 1 over cosine theta. And lastly, cotangent theta, which is 1 over tangent theta. We should always familiarize these 6 important trigonometric ratios, for they are the key aspects in learning the basics of trigonometry that could be applied in a more advanced level. Our next stop is common trigonometric identities. As you can see, that these are some of the most common trigonometric identities. These can be derived from the fundamental Pythagorean trigonometric identity, which is the sine theta plus cosine theta. Precisely, on the upper left corner, sine squared theta plus cosine squared theta is equal to 1. Underneath it is 1 plus tangent squared theta, which is equal to secant theta. On the lower left corner, it is expressed as 1 plus cotangent theta, which is then equal to cosecant theta. We could also achieve a lot of other trigonometric identities such as cosine squared theta that is equal to 1 minus sine squared theta. As you can see, this is derived from the identity in the upper left corner mentioned earlier, which is the sine squared theta plus cosine squared theta that is equal to 1. This rule could also be applied in other trigonometric identities as long as it follows the basic concepts of mathematical derivations. A few tips to remember. Always start from the more complex side. Express everything into sine and cosine. Remember your common identities and always practice. Let's move forward to example number 1. In this problem, we have to prove that tangent theta is equal to sine theta times secant theta by verifying them. In this problem, we choose to verify the sine theta times secant theta, for it is the challenging one and the one that is mostly needed to be simplified. So first, we need to copy the sine theta and use the reciprocal identity of secant theta, which can be expressed as 1 over cosine theta. When we multiply them both, we get the result of sine theta over cosine theta, and based on the quotient identities, sine theta over cosine theta is equal to tangent theta. Therefore, we can prove that tangent theta is equal to sine theta times secant theta. For the second problem, our aim is to prove that secant theta is equal to sine theta times tangent theta plus cosine theta. The same thing we did in our first problem, we need to verify the challenging one and the side that is mostly needed to be simplified. And in this case, it is the sine theta times tangent theta plus cosine theta. The first thing we need to do is to use the rule of quotient identities and convert tangent theta to sine theta over cosine theta in order for us to combine it with the sine theta. This leads us to a product of sine squared theta over cosine theta plus cosine theta. For us to add these two fractions, we need to have the same denominator. That is why we need to multiply cosine theta with cosine theta over cosine theta for us to achieve the result of cosine squared theta over cosine theta. Now that both of our fractions have the same denominator, we can combine them into one fraction. This leads us to sine squared theta plus cosine squared theta over cosine theta. Based on the Pythagorean identity rule, sine squared theta plus cosine squared theta is equal to 1, which makes the fraction equal to 1 over cosine theta. Based on our reciprocal identity rule, that 1 over cosine theta is equal to secant theta. Therefore, we can prove that secant theta is equal to sine theta times tangent theta plus cosine theta. For problem number 3, we now need to prove that secant squared theta is equal to 1 plus tangent squared theta. The same as we did in the earlier problems, we will verify and simplify the challenging one, which is on the right side. So first, we can express tangent squared theta as sine squared theta over cosine squared theta following the rule of quotient identities. We can also express 1 as cosine squared theta over cosine squared theta in order for us to add and combine similar terms. Specifically, since they have the same denominator, we could simply follow the rule of fractions where cosine squared theta over cosine squared theta plus sine squared theta over cosine squared theta is equal to cosine squared theta plus sine squared theta over cosine squared theta. Following the Pythagorean identity rule, cosine squared theta plus sine squared theta is equal to 1. This left us with 1 over cosine squared theta. Following the reciprocal identity rule, 1 over cosine squared theta is equal to secant squared theta. Therefore, we can prove that secant squared theta is equal to 1 plus tangent squared theta.
That's all for now. Thank you for watching and please don't forget to subscribe and like to our YouTube channel.